On the afternoon of January 31st, 2,088 people boarded Alaska Airlines Flight 261 in Puerto Vallarta, Mexico. They were heading home. Vacations were over. Sunburns were fading. Not one of them would make it back. What happened over the Pacific Ocean that day would become one of the most devastating crashes in American aviation history. And the most disturbing part was not what failed. It was that someone had warned the airline it was going to fail. 2 years before it did. The aircraft was a McDonnell Douglas MD-83, registration November 963 Alpha Sierra. It was 8 years old, delivered new to Alaska Airlines in 1992. By January 2000, it had logged over 26,000 flight hours across more than 14,000 flights. On paper, the airplane was well within its operational life. Nothing in the logbook from the previous crew flagged any problems. No warnings, no write-ups. The jet had flown into Puerto Vallarta that morning without incident. The captain was Ted Thompson, 53 years old, from Redlands, California. He had spent 8 years flying C-141 cargo planes in the United States Air Force before joining Alaska Airlines in 1981. By the time he climbed into the left seat that afternoon, he had more than 17,700 flight hours to his name. Over 4,000 of those were on the MD-80. He was also a flight safety instructor for the company. If anyone knew that airplane, it was Ted Thompson. In the right seat was First Officer Bill Tansky, 57, a former Navy pilot living in Alameda, California. He had been with Alaska Airlines since 1984, 15 years. He had accumulated over 8,000 hours on the MD-80. It was practically the only airliner he had ever flown. He knew its systems the way a mechanic knows a wrench. 3 flight attendants completed the crew. Allison Shanks, 33, who had been with the airline for 12 years and was raising a young daughter on her own in Seattle. Craig Polanco, 30, traveling that day alongside his partner, who was seated in the cabin as a passenger. And Kristen Mills, 26, the newest of the 3, still settling into what she called her dream job. 83 passengers filled the cabin behind them, families returning from vacation, couples, children. Among them was Morris Thompson, a former commissioner of the Bureau of Indian Affairs in Alaska, traveling with his wife Thelma and their daughter Cheryl. 47 of the passengers were headed all the way to Seattle. 30 were getting off in San Francisco. The rest were connecting onward to Eugene and Fairbanks. Flight 261 pushed back from the gate at Puerto Vallarta just after 1:37 in the afternoon Pacific time. The weather was clear. Visibility was excellent. First Officer Tansky took the controls for the first leg to San Francisco. He hand-flew the aircraft off the runway and up through 6,000 feet before engaging the autopilot. The airplane climbed smoothly toward its cruising altitude of 31,000 feet. Somewhere behind the cabin, mounted high inside the tail of the airplane, a component called a jack screw was holding the horizontal stabilizer in place. That stabilizer is what keeps the nose of the aircraft pointed where the pilots want it, up or down. The jack screw is a steel rod about 22 inches long, threaded through a small brass nut. When the system works, it works invisibly. Passengers never know it exists. Pilots rarely think about it. But inside that nut, the threads had been wearing down for months. Metal grinding against metal without enough grease to protect it. The part had last been lubricated 5 months earlier, in September of 1999. The next full inspection was scheduled for March, just 2 months away. It would not make it to March. If you want to hear what the cockpit voice recorder captured when that jack screw finally let go, like this video and subscribe. It really helps. Back to Flight 261. As the airplane leveled off above the Pacific coastline, everything in the cockpit appeared normal. The autopilot was holding altitude, airspeed was steady, the sky ahead was clear. Ted Thompson and Bill Tansky had no reason to believe this flight would be anything other than routine. But deep inside the tail, the threads on that brass nut had less than 2 hours left. For the first hour, nothing seemed wrong. Flight 261 climbed through the lower altitudes, passed over the coastline of mainland Mexico, and headed north-northwest over the Pacific Ocean toward California. The cabin crew began their service. Passengers settled in for the 3.5-hour flight to San Francisco. But as the airplane climbed through 23,400 feet, something changed. Deep inside the tail, the worn threads on the brass nut finally gave way. They stripped off the jack screw and curled around the steel rod like a metal ribbon. The horizontal stabilizer, which had been moving freely up and down for 8 years, locked in place. It jammed slightly nose down. In the cockpit, the autopilot began struggling. It was trying to hold altitude and climb rate, but the airplane was not responding the way it should. Thompson and Tansky noticed the trim system was not working. They followed their training. They disengaged the autopilot and began troubleshooting. The checklist called this a jammed or runaway stabilizer. They tried the primary trim. Nothing. They tried the alternate trim. Nothing. The stabilizer would not move. The airplane could still fly. The elevators on the tail were still working, and the pilots could use them to control pitch manually. But it took constant pressure on the control column. The workload had just doubled, and they were still over 2 hours from San Francisco. Thompson and Tansky managed to coax the airplane up to its cruising altitude of 31,000 feet. They held it there, but the effort was noticeable. The jet wanted to nose down. They had to keep pulling back to keep it level. This was manageable for now, but both men knew it was not a situation they wanted to live with all the way to San Francisco. At 3:49 in the afternoon, more than 2 hours after the stabilizer had jammed, Captain Thompson contacted Alaska Airlines maintenance facility in Seattle on the company radio frequency. He explained the problem. Maintenance confirmed there were no known issues with the aircraft. The discussion quickly turned to what to do next. By this point, Flight 261 was approaching the coast of Southern California. Los Angeles was behind them to the southeast. San Francisco was still over 300 miles ahead. Thompson wanted to divert to Los Angeles. The conditions were better. The runways were longer, the weather was good, and Alaska Airlines had a full maintenance operation at LAX that could handle whatever was wrong with this airplane. But the dispatcher in Seattle had a different idea. He wanted the flight to continue to San Francisco. The reason had nothing to do with safety. It had to do with the schedule. A diversion to Los Angeles would disrupt the airline's flow of connecting flights. The dispatcher told the crew he was concerned about the effect on operations. Thompson pushed back. He was polite, but firm. He told dispatch the airplane was not going anywhere for a while once it landed. This was not something that could be fixed on a quick turnaround. After the call, he vented to Tansky in the cockpit. The dispatcher's attitude, he said, just drives me nuts. They were dealing with a jammed flight control, and the airline was worried about schedule. At 3:55, the dispatcher came back with weather information for both airports. Thompson made his decision. They were going to Los Angeles. Tansky agreed. First Officer Tansky then picked up the cabin interphone and addressed the passengers. He kept his voice calm and professional. "Folks," he told them, "we have had a flight control problem up front here. We are going to be diverting to Los Angeles." He did not elaborate. In the cockpit, the two pilots began preparing for the approach into LAX. They needed to descend from 31,000 feet. They needed to configure the airplane for landing. And they needed to figure out how the aircraft would handle at lower speeds with the stabilizer locked in place. Neither of them had ever practiced this exact scenario. No one had. Thompson turned to Tansky. He wanted to try one more thing before they started down. The primary trim motor. Maybe if they ran it again, the stabilizer would break free. It was a reasonable decision. It was the decision the checklist pointed toward. And it was the decision that would change everything. The captain reached for the trim switch. The stabilizer moved. At 4:09 in the afternoon, Captain Thompson activated the primary trim motor one more time. The stabilizer moved. For a brief moment, it must have felt like relief. But what happened next was the opposite. The threads that had been holding the jack screw in place were already gone. When the motor forced the screw to turn, the stabilizer did not stop where the pilots wanted it. It drove the nose of the airplane down, hard. Flight 261 pitched over and began to dive. The overspeed warning fired. The altimeter started unwinding. 31,000 feet, 30,000, 29. The airplane was accelerating toward the ocean, and the pilots were pulling back on the control columns with everything they had. At 4:09 and 52 seconds, Thompson keyed the radio. His voice was strained, but controlled. "Center, Alaska 261. We are in a dive here." 2 seconds later, he added, "And I have lost control. Vertical pitch." The overspeed warning was screaming in the background. It would not stop for 33 seconds. At 4:10 and 6 seconds, the controller asked him to repeat. Thompson responded, "Yeah, we are out of 26,000 feet. We are in a vertical dive. Not a dive yet, but we have lost vertical control of our airplane." 20 seconds later, his voice came through again, quieter this time. "Just help me." They were falling at nearly 10,000 feet per minute. The passengers in the cabin had no control surfaces to grab, no instruments to read. They had only the sound of the engines and the feeling of the floor dropping away beneath them. The flight attendants had been told to take their seats, but the pilots fought. Thompson and Tansky pulled back together, coordinating their inputs. Slowly, agonizingly, they managed to arrest the descent. The airplane leveled off around 24,000 feet. They had fallen nearly 8,000 feet in under 2 minutes. Tansky said it first. "Whatever we did is no good." Thompson agreed. "I think the stab trim thing is broke." They both understood now that the stabilizer system was not jammed. It was broken. Something fundamental had failed inside the tail, and any attempt to use the trim again could send them into another dive. They stabilized the aircraft. The elevators still responded. The engines were running, but the airplane wanted to pitch down constantly, and the only thing keeping it level was brute force on the control column. This was survivable, for now. At 4:15, the Los Angeles approach controller asked if they wanted to start descending for the approach into LAX. Thompson's response would later be cited in the NTSB hearings. "I need to get down to about 10, change my configuration, make sure I can control the jet. And I would like to do that out here over the bay if I may." He did not want to fly over neighborhoods and houses while testing whether this airplane could still land. He chose the ocean instead. They began a slow, careful descent. 17,800 feet. The pilots discussed their plan. Lower the landing gear. Extend the flaps incrementally. See how the airplane responded at each step. Tansky and Thompson traded control inputs. They were methodical. They were calm. At 4:19, the cockpit voice recorder picked up 4 distinct thumps from the tail of the airplane. Something was breaking apart back there. 17 seconds later, at 4:19 and 36 seconds, an extremely loud noise erupted from the rear of the aircraft. The jack screw had separated from what was left of the nut entirely. The horizontal stabilizer swung to a position far beyond its design limits. The nose was forced down violently. Flight 261 pitched over to nearly 70 degrees nose down and began rolling to the left. In the cockpit, Tansky keyed the radio. One word: Mayday. Pilots from other aircraft in the area watched it happen. One radioed the controller. "That plane has just started to do a big, huge plunge." A SkyWest crew reported, "He is definitely out of control." The airplane was upside down now, pointed at the Pacific Ocean, falling at over 18,000 feet per minute. Thompson and Tansky were still pulling on the controls. The cockpit voice recorder captured them working together until the final second. At 4:21 in the afternoon, Flight 261 struck the water between the coast of Port Hueneme and Anacapa Island. All 88 people on board were killed on impact. The first reports reached the Coast Guard within minutes. Pilots who had watched the airplane go down gave coordinates. Fishing boats in the area turned toward the impact site. By the time the sun began to set over the Channel Islands that evening, small vessels were already pulling debris from the water. Seat cushions, luggage, clothing, personal belongings. The remains of 88 people who had been alive less than an hour earlier. The Pacific Ocean off the coast of Southern California is not shallow. Where Flight 261 went in, the water was roughly 700 feet deep. The main wreckage field was spread across a wide area of the ocean floor. The fuselage had broken apart on impact. The wings had separated. Both engines lay on the bottom, buried in sediment. The National Transportation Safety Board launched a full investigation team the same night. Greg Phillips was named the investigator in charge. Within 48 hours, the NTSB had assembled more than a dozen working groups covering everything from aircraft systems and maintenance records to air traffic control communications and human factors. But before any of that analysis could begin, they needed two things from the bottom of the ocean: the flight data recorder and the cockpit voice recorder. Without them, the investigation would be working blind. The Navy sent the remotely operated vehicle Scorpio, deployed from the vessel MV Kelly Truist. Divers and underwater cameras scanned the wreckage field methodically, square meter by square meter. On February 2nd, 2 days after the crash, the ROV's robotic arm closed around an orange cylinder resting in the debris. It was the cockpit voice recorder. The flight data recorder was recovered shortly after. Both units were sent to the NTSB laboratory in Washington. Engineers opened them carefully. The flight data recorder had captured hundreds of parameters across the entire flight, from pushback in Puerto Vallarta to the final second of impact. The cockpit voice recorder had recorded the last 31 minutes. When investigators in the CVR laboratory pressed play, the room went quiet. They heard two professional pilots calmly working a problem they had never trained for. They heard Thompson and Tansky coordinating control inputs, discussing options, consulting checklists. They heard Thompson tell approach control he wanted to fly over the ocean, not over populated areas. They heard the four thumps, the loud noise, and then both men fighting for control of an airplane that was pointed straight down until the recording stopped. NTSB board member John Goglia would later describe the CVR as one of the most difficult recordings he had ever listened to, not because the pilots panicked, because they never did. While the recorders were being analyzed, recovery teams continued working the ocean floor. Using side-scan sonar, remotely operated vehicles, and a commercial fishing trawler, they brought up roughly 85% of the fuselage, including the entire tail section. Both engines were recovered, and critically, the horizontal stabilizer and its trim system were pulled from the wreckage. When investigators laid out the jack screw assembly on the examination table, they saw the problem immediately. The steel jack screw, about 22 inches long, was intact, but the brass nut that was supposed to hold it in place had no threads left. The threads had been ground away almost entirely. 90% of the thread material was gone. What remained had sheared off and was found wrapped around the screw like a thin metal coil. There was no grease anywhere on the assembly. The surfaces where lubrication should have been were completely dry. Metal had been grinding against metal, unprotected, for what appeared to be a very long time. The investigators now had their answer to what had failed: a single component. A brass nut smaller than a fist, designed to hold the horizontal stabilizer of a 140,000-pound airplane in position. It had worn down to nothing. But the question that mattered more was not what failed, it was why. Why had the threads worn down this far? Why had no one caught it? And why had a part that was supposed to last 30,000 flight hours disintegrated in just over 26,000? The answers were buried in the maintenance records, and what investigators found there was far worse than a broken part. To understand why that brass nut failed, investigators had to go back more than a decade. Not to the flight itself, not even to the last inspection, but to a pattern of decisions that had been quietly building inside Alaska Airlines since the mid-1980s. The jack screw assembly on the MD-83 was not complicated. A steel screw threaded through a softer brass nut. When the motor turned the screw, the nut moved up or down, tilting the horizontal stabilizer to control the pitch of the airplane. To keep it working, the nut needed two things: regular lubrication and periodic inspections to measure how much the threads had worn. When the DC-9 was originally certified, McDonnell Douglas recommended lubricating the jack screw every 300 to 350 flight hours. That meant maintenance crews would open a small access panel in the tail, apply grease to the screw, and check that the system was functioning. It was a simple job. It took about 4 hours to do properly. But starting in 1985, Alaska Airlines began requesting permission from the FAA to extend those intervals. They wanted more time between lubrications and more time between wear inspections. The FAA approved every request. By 1996, the lubrication interval had been stretched from 350 flight hours to the equivalent of roughly 2,500 flight hours. more than 7 times the original recommendation. The wear inspections went from every 5,000 flight hours to every 30 months, which at Alaska Airlines' utilization rate meant nearly 9,500 hours between checks. Think of it like a car engine. The manufacturer says change the oil every 3,000 miles. You decide to do it every 20,000 instead. The engine might survive for a while, but every mile without fresh oil is a mile closer to the point where the metal starts grinding itself apart. That is exactly what happened inside the tail of November 963 Alpha Sierra. The last wear inspection on the accident aircraft had been performed in September of 1997 during a C-check at Alaska Airlines maintenance facility in Oakland, California. A lead mechanic measured the end play on the jack screw. End play is the amount of movement in the nut, and it tells you how worn the threads are. The more play, the more wear. The mechanic found the nut was worn to its maximum allowable limit. He wrote up a work order to replace the entire jack screw assembly. That should have been the end of the story. The part would have been swapped. The airplane would have flown safely. 88 people would have gone home. But the next shift overruled him. A different team rechecked the measurement 5 times and recorded a number that was within limits. The replacement order was canceled. The airplane was put back into service with the worn part still installed. That mechanic's name was John Leotine, and what happened next made the story even darker. In 1998, Leotine went to the FAA. He told federal investigators that supervisors at Alaska Airlines were signing off on maintenance that had not been properly completed. He said records were being falsified to get airplanes back into service faster. He secretly recorded conversations with his supervisors as part of the federal investigation. In August of 1999, Alaska Airlines put Leotine on paid leave. 5 months later, Flight 261 crashed. The NTSB also discovered that the last lubrication of the accident jack screw, performed in September of 1999, was done improperly. The job should have taken 4 hours. Records indicated it was completed in roughly 1 hour. The grease fitting that was supposed to deliver lubricant to the nut threads was found plugged with dry residue. Fresh grease had been applied on top of old, contaminated grease. It never reached the surfaces that needed it, so the threads wore down. Month after month, flight after flight, metal grinding against metal with nothing to protect it. By the afternoon of January 31st, 2000, 90% of the thread material was gone. The nut was holding on by the thinnest possible margin, and when Captain Thompson activated the trim motor one last time, that margin disappeared. But Alaska Airlines was not the only one responsible. The investigators were about to turn their attention to the people who were supposed to be watching. The Federal Aviation Administration is supposed to be the last line of defense. When an airline cuts corners, when maintenance gets sloppy, when intervals get stretched too far, the FAA is the agency that is supposed to step in and say no. In the case of Alaska Airlines, it did not. Every time Alaska Airlines requested permission to extend the lubrication interval on the jack screw, the FAA approved it. Every time the airline asked for more time between wear inspections, the FAA signed off. Investigators found that in most cases, the FAA did not independently evaluate whether these extensions were safe. They simply accepted whatever documentation the airline provided. In 1996, when Alaska Airlines applied to push the lubrication interval out to 8 calendar months, an FAA inspector reviewed the request. His testimony during the NTSB hearings revealed that the airline had submitted documentation purportedly from McDonnell Douglas as justification. But when the NTSB dug deeper, they could not determine what specific information Alaska Airlines had actually provided to the FAA before 1996. Nobody could produce the paperwork, and none of the original engineers at McDonnell Douglas had approved or even been consulted on the change. The same year, Alaska Airlines extended its C-check interval from 13 months to 15 months. The FAA approved that too. Because the jack screw wear inspection was tied to every other C-check, this quietly pushed the inspection interval from 26 months to 30 months. That translated to roughly 9,500 flight hours between checks, while the manufacturer recommended no more than 7,200. The FAA never assessed the effect of the C-check extension on individual maintenance tasks. They approved the whole package without looking at the parts. After the crash, the NTSB ordered a special inspection of Alaska Airlines. What they found went far beyond the jack screw. Investigators uncovered widespread deficiencies across the airline's entire maintenance operation. Key management positions in the safety department had been left unfilled. Oversight was inconsistent. Record-keeping was unreliable. The NTSB concluded that FAA surveillance of Alaska Airlines had been deficient for at least several years. The agency that was supposed to protect the flying public had been looking the other way. But there was another layer to this failure: the airplane itself. The jack screw assembly on the MD-80 was designed with two independent sets of threads. Each set was strong enough to carry the full load on its own. The designers at McDonnell Douglas assumed that at least one set of threads would always be present. If one set wore down, the other would still hold. Because of this assumption, the jack screw was certified without any fail-safe mechanism. There was no backup system, no secondary nut to catch the screw if the primary threads failed, no warning light in the cockpit to tell the pilots the threads were deteriorating. The entire design relied on one thing: that the maintenance would be done correctly, that the grease would be applied on time, that the inspections would catch the wear before it became critical. Remove any one of those layers, and the system had nothing left. Alaska Airlines removed all of them. And this was not the first time a jack screw had caused problems. In the years before the crash, other airlines had reported excessive wear on the same component. Some had found jack screws worn well beyond acceptable limits during routine inspections. The information was available. The pattern was visible. But nobody connected the dots. NTSB board member John Goglia wrote in his final statement that this was a maintenance accident. He said that Alaska Airlines' maintenance of the horizontal stabilizer system was poorly conceived and woefully executed. He said the failure was compounded by poor oversight. And he added one sentence that cut to the core of the entire case. Had any of the managers, mechanics, inspectors, supervisors, or FAA overseers whose job it was to protect this mechanism done their job conscientiously, this accident cannot happen. 88 people were dead. A mechanic had tried to sound the alarm. The airline had silenced him. The FAA had looked the other way, and a design with no backup had been left exposed to the one thing it could not survive: neglect. Now, something had to change, and it was about to. The NTSB issued 24 safety recommendations in the wake of Flight 261. More than half were directly related to jack screw lubrication and wear measurement. The scope of the changes that followed would reach every MD-80, MD-90, and Boeing 717 in the world. The lubrication interval on the jack screw assembly was immediately cut back to every 650 flight hours. No extensions, no exceptions. Airlines were required to remove old grease completely before applying new lubricant, rather than layering fresh grease on top of contaminated residue. The FAA mandated that every lubrication be treated as a required inspection item, meaning a certified inspector had to sign off on the work before the airplane could return to service. No more one-hour shortcuts on a 4-hour job. The wear inspection interval was tightened to every 2,000 flight hours. The NTSB also recommended that a more accurate method of measuring thread wear be developed, because the tools Alaska Airlines had been using were found to produce unreliable results. New in-play check procedures were written and distributed to every operator. But the recommendations did not stop at maintenance schedules. The NTSB went after the design itself. They called on the FAA to require a fail-safe mechanism on the jack screw assembly, a redundant nut that would catch the screw if the primary threads failed. Engineers at NASA and the United Space Alliance developed the fix. The redesigned assembly included a secondary follower nut that would assume the full load in the event of primary nut failure. It also made the jack screw easier to access for inspection, so maintenance crews would no longer have to work through a tiny access panel to reach a critical flight component. The FAA was ordered to stop approving maintenance interval extensions without requiring the airline to provide supporting engineering data. No more rubber stamping. Every extension would now need a task-by-task justification, showing that the change would not introduce a safety risk. Airlines were directed to train their dispatchers and maintenance controllers not to pressure flight crews into continuing flights when a serious malfunction had been reported. The culture that had put schedule ahead of safety was named directly in the report. The NTSB also recommended that pilots be instructed not to troubleshoot inoperative flight controls repeatedly. The checklist should be followed once. If the system does not respond, leave it alone. The investigation into Alaska Airlines maintenance operations continued for years after the crash. A special FAA inspection uncovered deficiencies so widespread that the NTSB questioned whether the airline's corrective actions went deep enough. In July of 2001, an FAA panel determined that Alaska Airlines had addressed the problems. But the NTSB remained skeptical, noting concerns about the overall adequacy of the airline's maintenance program. John Leontine, the mechanic who had recommended replacing the jack screw 2 years before the crash and then reported maintenance fraud to the FAA, settled his libel suit against Alaska Airlines in 2001. The airline paid approximately $500,000. As part of the settlement, Leontine resigned. Federal prosecutors announced they would not file criminal charges against Alaska Airlines. Captain Ted Thompson and First Officer Bill Tansky were posthumously awarded the Airline Pilots Association Gold Medal for heroism. The award recognized what the cockpit voice recorder had made unmistakably clear. Two pilots who never stopped fighting for their airplane, their crew, and their passengers from the first sign of trouble to the last second of the recording. A memorial sundial was built at Port Hueneme on the California coast, designed by artist James Bottoms. The names of all 88 victims are engraved on individual bronze plates around its perimeter. Every year, on January 31st, at 4:22 in the afternoon, the sundial casts a shadow across a memorial plaque. The exact minute Flight 261 hit the water. If this story meant something to you, take a second and hit like. That one click is how YouTube decides whether to show this to someone else. And if you want to hear the next one, subscribe and turn on the bell. We are not running out of these stories anytime soon. Every flight has a lesson. Every investigation has a truth that somebody tried to bury. Drop a comment and tell us where you are watching from. United States? United Kingdom? Canada? Somewhere we have never heard of? We read every single one. This channel exists because people like you keep showing up. And as long as you do, these stories and the people in them will not be forgotten. 88 people lost their lives on Flight 261. But because of what investigators found on the ocean floor, every jack screw on every MD-80, MD-90, and 717 in the world was re-inspected, re-lubricated, and redesigned with a failsafe that did not exist before. And that change has been protecting every single person who has boarded one of those airplanes ever since. Thank you for watching, and thank you for being here.